I thought I'd do a quick rundown of the complete motor or driver pressing operation. Just an overview of some of the changes I've made in that process since the last video. I know it takes 65 grams of any of the propellants to make one of the motors or drivers. 67. 65 grams. As always in the shop, I'm completely containing everything and minimizing exposure. I've got a waxed tube I will use. I've got the pressure on the press set to 3,300 pounds of force, which will put 7,500 pounds per square inch on the composition here. Put my nipple base in there. I've cut the nipple down to 3/8 of an inch high. I've got the safety shield on the press now, and I put the clamshell in there in such a way that the split in the clamshell is running front to back. If God forbid anything ever happened when I'm pressing this motor, the two halves of the clamshell will blow side to side and not toward me and the press. I'm pressing at a half tablespoon of the composition at a time. So that is a pressed motor. That is a pressed motor then. What I want to do is I'll press a bulkhead, either a solid clay bulkhead or a bulkhead with a pacifier hole in it. In this case I'll press one with a pacifier hole in it. I use about a teaspoonful of graphited Dr. Elsey's clay cat litter. I put a funnel in there. This goes right down to the top of the whistle propellant. Put a funnel in there, insert the spindle for the bulkhead forming tool down in there, drop the clay around the spindle, remove the funnel, and then drop the rammer over the spindle and compress that clay as much as possible. So that's got the spindle going right down to the top of the whistle. I'll take this over to the arbor press and press it. I just press that till it's solid. I'm not really calibrating how much force I'm putting on there till it stops pressing. Move the rammer and the spindle, and that produces a bulkhead with a nice pacifier hole in there to make sure to clean all the clay out of the rammer and off of the spindle. And then I've got a drill bit just a little bit smaller than the diameter of the spindle for the bulkhead pacifier hole forming tooling. And I'm just going to very gently, there's no metal in that whistle propellant, so I'm just very gently going down about a 1/16 of an inch into the whistle and make sure I'm really into that propellant. Just hand twist drilling gently. And now that's got a nice clean bottom to that pacifier hole. So there's a motor with a pacifier hole through a clay bulkhead. And I will make 12 of those whistle motors, and I'll do the same process with the glitter and titanium drivers. Well, I now have 6 whistle drivers with clay bulkheads without pacifier holes, 6 whistle drivers, whistle motors with pacifier holes through the clay bulkheads. The reason I only have pacifier holes through 6 of the motors, clay bulkheads, is I'm going to use 6 1-inch cross sets as headings on this. These cross sets alone weigh 7 ounces, plus I'll be using a little bit of a BP lift charge and some tape to attach them, so they'll bring that total up to about 8 ounces, which is what I wanted in terms of a heading weight. So I'm only going to have a cross set on every other vertical motor for only 6 of the cross sets. I have 2 titanium drivers, flat fuel grain end on one end, that's the thrust end, and then bulkheads with pacifier holes through the top of them to pass fire after they burn to the glitter drivers and the vertical whistle motors. And I've got 2 glitter drivers with solid clay bulkheads and the flat glitter grain ends for their thrust ends. They'll create that glittering umbrella of glitter as the machine spins and then gradually lifts off and flies. What I'm doing nowadays for nosings on motors like this, I have this tape shooter with 1.5-inch white tape, and I think it's about 35-pound tape. And I am using enough of that. These are the whistle motors without the drilled pacifier holes. I'm using that tape. I've ejected enough tape to go put 2 turns of the tape on the thrust burning end of these whistle motors. So that's how I'm applying the nosings on these motors nowadays. So I will go ahead and put nosings on the bottom ends of each of the whistle motors, the thrust end of the glitter motors, and both ends of the titanium drivers. And then I'll show how that's all assembled onto the frame. This is one of the 3D printed frames I'll be using for this machine from Richard Oz Fireworks. So all of those are nosed the way I described. This is the frame I'm going to use. These motors, this is a motor without a pacifier bulkhead hole. I want to install these motors, the vertical whistle motors. Every other one will be one without a pacifier hole, and therefore every other one will be one with a pacifier hole to mount the crossettes on. I want to install these with about 1 inch of the motor sticking above the frame. The bottom part of these motors burn a little bit away, and I don't want to get in the frame. I'd like to be able to reuse this frame. So I'm going to be installing the motors. What I do is put a clove hitch of string above and below the frame on the motors with a little bit of bead of white glue on there to keep the string from sliding. And that way, after this has flown, hopefully I can find it and easily remove those string retaining rings and pull the motors out and reuse the frame. Hopefully the frame will be reusable, at least that's the idea. So every other one of these motors, there's one without a pacifier hole, there's one with a pacifier hole, and I'm going to go around the frame and install them, and I'll be putting clove hitches of string above and below the frame on these motors in order to secure them in place. There then are the 12 whistle motors, every other one with a bulkhead pacifier hole that will receive these 1-inch cross-set heading on every other one at the final step of assembly. These motors are all now attached, about 1 inch sticking above the frame with a string tie top and bottom and some glue on the string tie to keep them from sliding. In the first video you see a bucket bottom, a 5-gallon bucket bottom that I use as a frame. That's another alternative for a frame for one of these small Girandolas, or a person could make, similar to the Girandolas demoed in the articles about Girandolas, a small wood frame with either split bamboo or half-round reed could be assembled. The diameter of this particular frame is about 12 inches, 11.5 inches. So that's the diameter I'm using on this. So something, an alternative type of frame could be used. Now what I'm going to do, this burn will start with the titanium drivers. You can see the angle on the whistle motors, the vertical whistle motors, is going to turn the frame this way. So the thrust end, the flat fuel propellant end on the titanium drivers, will face to the left in each of these cradles, one on one side of the frame, one on the other side of the frame. And then I will put the thrusting end of the glitter drivers in the other two cradles on opposite sides, 180 degrees apart, and then the whole rig will be fused together. The horizontal drivers are now attached, titanium on one side and directly the opposite on the other side, and the glitter ones. You can see how I have attached the drivers with the thrusting initially ignited ends off center. I'm trying to get these away from the frame as much as possible. So all these drivers are off center with the exhausting nozzle quote end as far away from the frame as possible. I did have one of my initial testing Girandolas where these drivers were centered. The spray from a titanium driver did melt the frame here and here as it hit the butt end of the glitter driver, which would have been about here, and it melted through the frame, and I lost one of my vertical motors in that location. So now I'm mounting all the drivers off center to get that spray as they burn as far away from the frame as possible and as far away from the end of the next driver as possible. Now what I will do is I will attach an ignition fusing from the thrust end of the two titanium drivers. I'll put a quick match connector between those with a piece of visco or an E-match in that. So the titanium drivers will light initially. They will burn spinning the Girandola horizontally. The interesting thing is that even without a nozzle, just flat end burning titanium drivers do have enough force to spin this on the stand. Then when they burn through, they will pass fire to the ignition ends of the glitter drivers as well as down to the ring of fusing, attaching all of the vertical motors, the whistle motors together. And so when the titanium drivers burn through, they're like the glitter drivers and the vertical whistle motors. And then finally I will attach the 6 headings to the machine. And there's the fused and finished Girandola. It's currently weighing 69.1 ounces. Once I subtract the 4.6 ounces for the titanium propellant and a couple ounces for the quick match, all of which will be lost before the vertical whistle motors and the glitter drivers ignite. Once I subtract that, the final flying weight is 62.5 ounces, which is exactly what I was shooting for. The ignition will occur. I've got the main ignition fuse and visco going across the top. That's tying the two titanium driver thrusting ends together. Then when the titanium drivers burn through, they will pass fire to the thrusting ends of the glitter drivers and also down to the ignition ring on the bottoms of the whistle motors. I've also installed the 6 cross-set, 1-inch cross-set headings on every other whistle motor. And that baby is ready to take to the display site and fly. So I'll get a video of that and I'll show you how it performs.